There is a moon in our solar system so violently active that its entire surface is reshaped by volcanoes every single year. Io is one of Jupiter's 4 large Galilean moons, discovered by Galileo Galilei in 1610. It is slightly larger than Earth's moon, but hides an extraordinarily violent interior beneath its colorful surface. Io has over 400 active volcanoes, far more than any other known body in the solar system. Some of its volcanic plumes shoot material as high as 500 kilometers above the surface. This makes Io's eruptions far more powerful than any volcanic eruption ever recorded on Earth. The moon's intense volcanism comes from a process called tidal heating, caused by Jupiter's overwhelming gravity. As Io orbits, it is constantly stretched and squeezed by the gravitational pull of Jupiter and neighboring moons. This flexing generates enormous friction and heat deep within Io's rocky interior, melting rock into magma. Io's surface is covered in sulfur and sulfur dioxide frost, creating its distinctive yellow, orange, and red colors. Early astronomers nicknamed it the pizza moon due to its mottled, colorful appearance resembling melted cheese and toppings. Unlike most moons, Io has almost no impact craters since constant volcanic activity buries them almost immediately. Scientists estimate the entire surface of Io is completely resurfaced by lava flows within just a few thousand years. This makes Io geologically the youngest-looking surface of any solid body in the solar system. NASA's Voyager 1 spacecraft made the historic discovery of active volcanoes on Io during its 1979 flyby. This was the first time active volcanism had ever been observed anywhere beyond planet Earth. Scientist Linda Morabito noticed a strange plume in a Voyager image while checking spacecraft navigation, leading to the discovery. Io's volcanoes eject not just lava, but sulfur dioxide gas that briefly freezes into snow before falling back to the surface. Temperatures at eruption sites can exceed 1,600 degrees Celsius, hotter than most volcanoes on Earth. Some of Io's lava is thought to be ultra-hot magnesium-rich rock, similar to lava from Earth's ancient early history. This gives scientists a rare window into what volcanic activity on early Earth may have looked like billions of years ago. Io has essentially no atmosphere to speak of, just a thin, patchy layer of sulfur dioxide gas that collapses at night. This thin atmosphere is constantly replenished by ongoing volcanic outgassing from the moon's active vents. Material ejected from Io's volcanoes escapes into space, forming a massive donut-shaped cloud of particles around Jupiter. This structure, called the Io plasma torus, is charged with ions that interact with Jupiter's powerful magnetic field. The interaction between Io and Jupiter's magnetic field generates powerful electrical currents between the two bodies. This flux tube carries millions of amperes of electrical current, creating auroras visible on Jupiter itself. Io's constant volcanic activity also strips away material, meaning the moon is slowly but steadily losing mass over time. Despite billions of years of eruptions, Io has not run out of volcanic material, thanks to continuous tidal heating. NASA's Galileo spacecraft studied Io extensively during multiple close flybys throughout the late 1990s and early 2000s. Galileo captured detailed images of lava lakes, glowing hotspots, and dramatic eruption plumes across the moon's surface. One of Io's largest volcanic features, Loki Patera, is a lava lake larger than the state of Rhode Island. This single volcanic feature periodically brightens and dims as its lava surface overturns and refreshes. Another Io volcano named Pele produces a massive red ring of sulfur deposits visible from space, hundreds of kilometers wide. Io's extreme radiation environment, caused by its proximity to Jupiter, makes it one of the most hostile places to explore. Jupiter's powerful radiation belts would quickly destroy unprotected electronics on any spacecraft orbiting too close to Io. This makes sending a lander directly to Io's surface an enormous engineering challenge for future missions. Despite these challenges, scientists remain eager to study Io as a natural laboratory for understanding tidal heating. Similar tidal forces are believed to drive volcanic and geological activity on icy moons throughout the outer solar system. Understanding Io helps scientists predict geological activity on exoplanets and moons discovered around other stars. Some exoplanets, called super-Io worlds, may experience even more extreme tidal heating than Io itself. Io's dramatic activity reminds scientists that moons, not just planets, can be geologically alive and dynamic. For centuries, scientists assumed small moons would be cold, dead, and geologically inactive like our own moon. Io shattered that assumption, revealing that gravitational forces alone can create extraordinary planetary scale activity. Io stands as a violent reminder that even a small moon, squeezed by the gravity of a giant planet, can burn brighter and more furiously than almost anything else in the solar system.